want to jump into the Enron data set, I'm going to walk through an actual investigation scenario. I'm going to use those technologies together in a really cohesive way. Companies buying their own stocks and maybe making these shell companies and hiding debt just to kind of make the share price look better. Executives are bonused on the share price and all that kind of stuff. So they were using mark-to-market accounting and basically realizing profits on things that hadn't even been done yet. And then they were also doing some things on the back end where they were amassing all of this debt, and then they were creating these shell companies that they called the Raptors, and they were sort of hiding some of the debt, selling some of that debt to those shell companies to just further amplify the stock price. Let's say I'm coming into the Enron data set now as an investigator. I'm like, look, I don't know very much about what's going on. I don't know the story yet, but I do know this has something to do with non-recourse debt and minority investors, some of these more kind of generic things that I can search for. So why don't I start with that? I'm going to start with the things I do know. So first of all, I don't want to look at duplicative data. When data is collected in an investigation, oftentimes it's collected across multiple custodians. They're typically PST files and mail stores, so the things that are underlying your Outlook inbox. Things like that are collected. They're hard drives, they're My Documents folders, SharePoint. Current collections, obviously there's a huge range of different sources, but most of them at their core are content. So there's a couple of steps that happen before the data gets into Brainspace, and we even have some mechanisms for loading data directly into Brainspace, but let's assume that we've gone through those steps first, and now the data has been collected and it's been loaded into Brainspace, and I'm ready to start looking at it. So the first thing I want to do is I'm going to run a search for one of the main terms that I know is part of this investigation. So I'm going to search for minority investor. It's a generic term. I want to get a sense of what's going on here. Before I actually apply that search, I'm going to filter down to just the unique documents because I don't want to look at redundancy. I want to shrink the footprint as much as possible with what I would call low or no risk filtering decisions, right? So duplicates, don't need to look at duplicates. So I'm going to filter it down to just unique documents. So I just quickly took that 1 million record set with a couple of clicks down to 358,000 records. And I really want to focus on specifically the year 2000. And I'm going to go ahead and now run this search, this concept search against that resulting data set. And there's 121 records now that come back in that range with those two other filters applied. So unique documents and from that time frame. Now, the cool thing about Brainspace is, remember earlier I said it lets you kind of test hypotheses. So if I want to trim out the 2000 filter for everything from the year 2000, I can very easily do that, but just by clicking on that search pill, and we'll do that really quickly. So right out of the gate, I'm seeing the things that are conceptually related to minority investor. My attention is immediately piqued by this friend of Enron. It just sounds kind of shady to me. So I'm going to go ahead and make that required. Find that, and there's one document that contains friend of Enron that comes back. So I'm going to take a look at this, and very quickly I see that, okay, provides an additional, in quotations, friend of Enron to facilitate short to medium term balance sheet and regulatory solution. Sounds like a bunch of kind of shady business going on here. And this last sentence is what really grabs my attention. That is that E&A would have a requirement that this investment be hedged through Raptor. Okay. Don't know what dinosaurs have to do with this, but I'm intrigued. So I want to now pivot on that Raptor search. And I've got 56,000 documents that contain Raptor. So what I'm going to do now is I'm going to make it required. So very quickly, I've just used Brainspace to go from this generic knowledge of knowing that minority investor is something I want to look for. I figured out that friend of Enron was the thing that was really interesting to me. And from friend of Enron, now I'm looking at Raptor. Just like that, just in a few minutes. And we actually demonstrated this years ago, one of the lead investigators that worked on Enron. And we were talking through sort of the process it took for them to find things like Merlin Credit Derivative and Chuco SLP and some of these other things that were related to Raptor. It took them months to find this stuff. And we were able to display for them in just a few minutes that they could just kind of click on a couple of things and here are these things. Now, they're not guaranteed to be positive hits or good examples of things that are going to be meaningful, but in this case, they really were. And so it provides a really powerful way to kind of see things that you don't know you're looking for very, very quickly. And it really shortens the time frame it takes to kind of gain that knowledge. And then, of course, you can take that knowledge and expand on it very, very quickly. So now that we're looking at Raptor, and we want to know, okay, what's the story with Raptor? There's a few different ways I can kind of pivot from here. So the first thing I want to do is I want to just look at things that contain Raptor because I really want to understand Raptor and only Raptor first. So there's 2,369 documents, and now I want to go even further and say just unique documents. So now there's 875 emails and attachments that I have to go through. The first thing I want to do is I want to go to our communications graph, which this is not using any machine learning. This is just using metadata and creating a visual representation of how people are interacting with each other via email around this topic and just unique documents. And so you can very, very clearly see who the key communicators are talking about Raptor. And Sarah Shackleton and Mary Cook are probably two of the key people here that are going to know what's going on. So one of the things I can do here, what you're actually looking at, it's called a network graph. That's the actual name of this type of visualization. We built our own from the ground up. And the whole point of this is to give you an at-a-glance understanding of who's communicating with who about what, and to give you sort of a sense of who the players are here. And we have two ways you can look at it. You can look at it by people, and you can also look at it by domains that are communicating with each other. So I'm going to flip over to domains. And one of the things I want to really focus on is communication between Enron and VE Law. That's their outside counsel. That's their law firm, Vincent and Elkins. So I'm going to click on that edge. And when I click on the edge, the cool thing about the edge, that's kind of like the conduit of communication between the domains. And you can see what the top terms are that they're communicating. So obviously there's a lot of communication about Raptor and things like that. So I'm going to focus on that by clicking on that and then adding that to my query. And now there's 3 documents specifically where VE Law and Enron are communicating. And I'm going to flip back to my people view now. And I can see all the people that are involved in communication about that. And very, very quickly, I understand who's involved. So Brent, I think this is Mark Spradling, Sarah Shackleton, Joel Efros, Trevino Maricela. And then we have a couple of people over here talking. What are they talking about? They don't really appear to be talking about the same. They're in a different conversation about Raptor. So I want to go ahead and add that query. Let's see what this email is about. It says, your group to oversee Raptor 3. So they're talking about this Raptor 3 thing. So really, I want to focus on the other one. So what I can do here is I can just quickly remove that, go back to the original 3, or I can go back to my search history, and anything that I've been doing here, I can go back to the previous state of the application. So all of that stuff is being kept track of as I kind of move through the visual cues and interact with these visual artifacts. You know, behind all of the things that are happening under the surface, one of the other key things about Brainspace that's unique is that we give you the ability to see the actual query that's being built. So if anybody wanted to replicate this search, this is the query that you'd have to be able to build. But it kind of demystifies it. You know, all the things that are happening behind the scenes in Brainspace, quite a bit of heavy lifting going on, but you don't have to be a PhD in search to be able to achieve these kinds of results. Whereas, you know, if you were to build this a traditional way using the Lucene and just basic search techniques, this is the kind of search you would have to be able to build. So it's a tremendous amount of sort of time savings and accessibility, and that's a big part of the user experience that Brainspace offers. It's one of our core competencies is that we demystify a lot of this really advanced technology and kind of hide it behind a really flashy UI. So when you find a document that you say, okay, this is interesting, I want this, what you can do is you can tag the document either positive or negative. And each one of these tags can be used to train a classifier. So what is a classifier? So it's basically you telling, right, the brain is an unbiased thing that just makes connections based on repeated patterns. But then if you pair that up with you telling Brainspace what you think is important or interesting, and you tag that with a positive tag, and then you tell Brainspace what is not interesting, you can then basically train this classifier and use those things together. You can use this sort of intersection of the unsupervised and supervised technology and do all kinds of really cool things. So in this example, this has been tagged as positive and negative in a few different classifiers, but I'm going to go ahead and just pretend like we tagged a few documents here, and I'm going to jump into the supervised learning interface and show you what this looks like. So what we've done is we've gone through, and this is a great example. This has been 7 training rounds. We tagged 66 positive examples and 17 negative examples. And what we do over time is we start to then, every time I tag a document or a series of documents, I can then rank the rest of the data set. And what it'll do is it'll give high ranks to things that are like what I'm looking for and give low ranks to things that are not what I'm looking for. And then I can use that score to sort of refine my results. So this is a histogram. And what this shows me is the distribution scores over the entire 1 million record data set based on 370 decisions made. So there were 370 coded documents, meaning that I tagged that many, and only 115 of them were positive, 254 were negative. And after those decisions were made, I built a classifier, and this is what I've got here. So what I have is I have a bunch of stuff kind of in this mid-range. What that lets me do is say I only want to look at things that are more likely to be positive, so I can set a cutoff here. I can actually go in and say trim and give me anything that's 0.85, 85% likely to be what I'm looking for or higher. And I can trim it. And instead of having to look at a million documents, now I only have to look at 466. And I can then go through and take action on that smaller subset of documents. So I can build a focus on it, and I can go through and I can even help train the classifier further. I can say, hey, at the very top of the pile, the decisions I make, the negative decisions that I make are more impactful, right? Because they're going to help really amplify the signal and decrease the noise, because I'm going to be decluttering sort of the top of my rankings. This is where you can kind of create this, what we call augmented intelligence, where the subject matter expert, the investigator, the analyst, the litigation support professional is using this combination of supervised learning and unsupervised learning to really make short work of large volumes of data. There's a couple of different scenarios here. So in the context of an investigation, the investigators are just going to go as far as they need to get the evidence or to tell a story to figure out where the gaps are. With a litigation scenario, what they're doing is, they're trying to, oftentimes they're just trying to meet a deadline. What they typically will do, there's two different workflows associated with what's called supervised learning or predictive coding. So they will agree to a certain target statistic up front with all of the involved parties that will say that, hey, we're going to give you 80% of the responsive documents, and we're about 95% sure of that. If you want 100%, we've got to code or review the entire 1 million record set. And a lot of people, they just don't have the time to do it. So there's got to be a negotiation there. So that's what's called predictive coding. Brainspace enables pretty much any workflow that you would use supervised learning for in the context of litigation and e-discovery. So using the same technology. So behind the scenes, what I'm building is a classifier. And if I take a classifier and I want to say, okay, I want to see what's behind that classifier. So I want to see a summary of all the decisions I made. We have this idea of a portable model. So a model is a distillation of a classifier. What does that mean? So I'll show you, because it's just easier to show you. And it really just demystifies this. The lawyers love this because they understand what's happening. These are the terms, and the higher the weight, the more relevant the term based on the trends that were established during my tagging. These are the terms that are driving scores up. And then if I scroll all the way down, I'll flip, there we go. These are the terms that are pulling scores down. So what does that mean? It means that more documents were tagged with the terms that are at the top here. So Shackleton shows up as a term, so that's a heavily weighted term. West Texas systematically, seismic imaging. These are things that are driving scores up. You can think of them as almost like balloons that are lifting things that are likely to be relevant and responsive to the top of the pile, and then vice versa with the negative score documents. So the cool thing about this is this model can be saved out and then used in another data set. So it's a way for enterprises, it's a way for law firms to sort of, in some scenarios, they can sort of store or save their IP. The result of all of those decisions that were made by lawyers and junior level associates and paralegals can be sort of stored, or it can be used to summarize things on the tail end of the project to give people a good sense of like what types of things were we seeing in those positive decisions.